Welcome to the lecture series on object oriented analysis and design. We are presently looking at object oriented methods, the early days of object oriented, the small methods which appeared very attractive because that is the kind of a problem which we are looking at. I do not need a method that works with 1 crore LOC to develop 50,000 lines of code. That is a feeling which we could not escape in the earlier days. However, as things turned out, as we became more and more experienced with object oriented analysis and design and methods and the languages, we began to understand that instead of fragmenting all our ideas in various other methods, we will have one unified modeling language. It does not matter, it demands 9 diagrams. Later on we started telling it demand more diagrams, does not matter, it is worth it. Then we said we can't be going through this drudgery, we need tools. We started talking about case tools. If the method is very clear, we can give a case tool that works, that checks the method. Like you check your syntax of a language, you can always check whether it is in conformance with the methods. Simpler methods were like this. We talked about Code-Udon method, just a set of notations which are nicely drawn by hand, explained, discussed, and it is very easy to understand with a little bit of mathematics. Schleiermacher method, this requires serious attention because it is a lot of notations. It is true that out there in the industry, in other engineering disciplines, they talk about so many notations very easily. They can put together construction of a building, for example, you talk to a civil engineer or better an architect, they will tell you so many things. They are all in different notations, but they all appear as a unified construct in their minds. Typically the architect is capable of doing that. They are all different. In theory, yes, somebody says electrical line, somebody tells plumbing line, they all have their own notations, but when they put together, that is a unified view. It is a nice idea we talked about. Now, all that we are looking at here is a series of notations which in themselves are very complicated for us. Each one is a different notation, and why are we so concerned about it? In the other engineering disciplines, the notation itself is some exercise. Here the notation is a representation of something which is very abstract. So, our focus is on what is this notation representing. So, we can keep on arguing, why this discipline is like this discipline is like that, compare and contrast we can always do, but the essence of this is here our interest is not on the notation is telling something, and that something is highly abstract. It is not something where we can quickly appreciate and relate to us. So, we keep talking about those early books, Booth's method for example. The early pages, the early chapters always talked about bird. Even in one of my lectures I was talking about a bicycle. Do you come across any context, any problem where you are going to talk about bicycle in your software? It is an example, tree is an example, rock is an example, but where do you come across all of that in typical software engineering? So, this notation is actually a representation of something like that. Our interest is what is that something. In the other engineering disciplines, a very hard engineering discipline, this is it. It only tells this, wherever you go on earth it is like this. So, there is a very good work which we keep on talking about, and Henri Dreyfus, he has compiled a wonderful work, a wonderful book on the standard symbolisms, communications, everything. The measures of the man, all symbols were all compiled by Henri Dreyfus. A few years after he passed away, it was published. It is an international success. Nobody really thought that all over for every human endeavor we do use notations, we do use symbolic communication, we talk in a manner which are gesticulations also. In many cases, a good portion of our communication is all kinesthetics. It is about what we do rather than what we speak. It is hardly 7% is actual documentable communication, 93% is what is called kinesthetics. So, it's an eye opener. It has been an eye opener that engineers across the world, engineering or anything to do with building things requires so much of symbolisms. Universal Handbook of Symbols, as Henri Dreyfus did it, and 2 to 3 years after he passed away, it was released as a public edition. So, it is a fact that all those symbolisms communicate this and nothing else other than this. That is the essence of all symbolisms. Here it is not this, it is a way it is communicating something else. We are interested in that something else at the earliest, because those something else's put together is what is making what we are trying to do as software engineers. So, there is a difference. So, we got completely perplexed, so many notations, so many symbols, and not much of tooling support. Now, into this one other thing came, business object notation, that is talking about seamlessness, reversibility, software contracting, 3 good ideas. These are all small ideas, but then they have been communicating very effectively that this is when we mean object oriented analysis. Different methods might have tried, but this particular notation was exceedingly good for what we have been trying for ages. Two-way traceability, very difficult. Reversibility, software contracting, an idea also fundamental in the Eiffel language. Next came one more language called Fusion. Fusion is influenced by existing, this is almost cited as an example where for the first time seemingly different methods were brought together to see how we can put them together. The idea is not new. You give 2 contracting things, the human mind would want to settle down somewhere in the middle. It is a very common idea. You present that this is one extreme, this is another extreme, is there somewhere midway which appeals to us? Very common in human endeavor. We like to do that. Now, we did this in languages. The very first attempt was like that, PL1. Lot of investment has gone, people were contacted, worldwide programmers were contacted, discussed, deliberated to find out why they have chosen a language of that choice for a problem. Putting them all together, they said these are the strong aspects, these are the features which will make a universal language, and PL1 was supposed to be that universal language which will do everything correctly, goodly, bestly for everybody. All terminologies and grammar may please be excused, but that is how it is. So, PL1 we created some nice notations, some terminology which is very specific. So, we put together all good ideas, good things across different languages and said this is the best language, it did not succeed. But the design of that language taught us very valuable lessons. We do not want to repeat that again, we are not really looking at a universal paradigm. We have a paradigm, it works like this within this scope. Fusion was one method, very first method that attempted to put together 3 seemingly different methods. Buch 91's abstract method, CRC, class, responsibility and collaboration, OMT, object modeling technique. So, object modeling technique and Buch 91 went a longer way. Into this came object oriented software engineering by Ivar Jacobson, his method came. CRC was replaced by OSE and they are dominating the unified modeling language. CRC is a very limited scope exercise involving about half a dozen people, very nicely documented, just exchange the cards, localized team of half a dozen people. We can have that online support now, it need not be physically co-located, we can do like that. Fusion is cited as a first method, but the core weakness remains this, an oversimplification, and we couldn't do much on that. Semantically rich method for OOA, SOMA, identify layers. Please remember the earlier discussion on hierarchy, identify layers, they were called levels in Schleiermacher method, identify objects, identify usage, define data semantics, add attributes to objects, add operations to objects, add the declarative semantics of the objects. We are very good in computing to come up to syntax, it is very fast. Syntax is something which all of us can do. What does it mean, the semantic, how does it relate to the problem, how does it relate to the context, the domain, that is a difficult exercise. This method is often cited for that semantical richness, which is not so much, it is still a small method. Again, please do recall that there are plenty of other methods, plenty. I have chosen only a few, my choice dominates, a few representative methods. Object oriented design methods. So far we have seen what are called analysis methods. Now we talk about design methods. By saying design methods, we are not telling that we are not doing analysis. They are not natively so good for top down. They are so wonderfully tuned to the basic idea of object oriented, that is bottom up. And we strongly think that the top down analysis will keep happening because decades of experience is there in top down analysis. We are exceedingly good in that analysis. Every problem solver, every puzzle solver innately is a top down approach analyst. So, that analysis is correct, but then you need a change of thinking. Many people are the subtle change of thinking. We strongly believe that lot of OA will keep happening. We do not have to worry about what fits for the purpose, most challenging, more specifically tuned to object oriented paradigm is object oriented design. Hierarchical object oriented design, HOOD. HOOD is an architectural design method helping a designer to partition the software into modules with well defined interfaces. In many ways, one of those disruptive practices brought along by the algorithmic computerization is a flat organizational structure. We cannot, in a process where there is lot of computerization, think of hanging on to the hierarchy and then keep thinking that it should all levitate upwards. The flat organizational structure is the first impact of what was called a good measure of computerization. We like to move around, that hierarchy vanishes automatically because any communication channel is okay. We are talking about a context where people do not even say one word extra in a business context, or the communication channels are completely defined and they cannot violate the communication channel. I can talk about my car, but I cannot talk about my director's car. So, these are all differences which we have been there, which were there. The very first impact of the algorithmic approach is that the flat organizational structure. Into this, we have to bring in a design that respects the hierarchy. That is very challenging. Into modules with well defined interfaces that can either be directly implemented or further partitioned into modules of lower complexity. So, the top big problem, sub problem, that hierarchy should be maintained. Otherwise, we lose the traceability of how I arrived at this sub problem. HOOD is a design approach that uses standardized textual and graphical formalisms to express the results of the design. A number of rules elaborated from industrial experience apply to the design, and these rules can be checked by automated tools. We do not have that many rules to tackle the complexity that we are talking. That is the only weakness in this method. If you can express everything as rule based, then yes, HOOD will succeed. We hope that as we progressed in object oriented, we will arrive at some rule base outside of what is obvious. For example, this mouse as a rule cannot be taken away from the machine. It is a rule, it is an obvious method, because on its own it does not do anything. Without this, the machine becomes useless or less effective, because you have a keyboard you can always use, but those of us who got accustomed to the mouse will feel handicapped if the mouse is not there. So, we have a rule, these two components must always go together, come whatever may, do not keep them separate. So, that is how we are talking about. HOOD rules are of three kinds: definitions, methodological rules and usage rules. HOOD supports identification of a software architecture after requirements analysis activities and leads naturally into detailed design, where operations of objects are further designed and implemented. A difficult and a very debatable idea, because we wish that software architecture happens up above the requirements. The architectural view, which brings together many things, HOOD has brought in the architecture, the idea of software architecture, to somewhere between requirements and specification, so that the detailed design will benefit. This has been disputed, this has been a matter of debate. It has its own notation. This is how the Hood notation is, include relationship, only one example is there. The other design method, OODLE, object oriented structured analysis, object oriented design language. The idea of bringing together all these things into one common language happened much before UML happened. However, the way things have happened has not resulted in such a resounding success. There were so many semantic gaps. The number one method by Booch 91 appeared to be the most comprehensive conceptual basis. Surprise, people were not taking it seriously because it is too abstract, talking about birds, mountains, rivers. Partition the system into domains, application service, architectural, domain chart is used to depict these domains and the interrelationship between them, which are referred to as bridges. Analyze the application domain, Schleiermacher's OSA. You can use it, you can use another method, if any analysis method can be used. OODLE is so flexible. If you like Schleiermacher's, you use it, otherwise you replace it by another analysis method of your choice. But then by splitting object oriented structured analysis, please remember that they did not want to come out of the structured analysis also and the design language, they gave that flexibility of changing the first one. OSA can be your choice, you can replace it, you can have any other analysis method. Verify the analysis through simulation. OODLE 2, there is a second slide, it is not OODLE 2 as another language. Extract the requirements for the service domain. The service domains may include the user interface and other external interfaces of the system. Analyze the service domains, specify the components of the architectural domain, build the architectural components, translate the OA models of each domain using the architectural components. OODLE notation, they have borrowed some from Schleiermacher. Easy to say rather than doing it, but it is a good idea. Simply follow this method, it has good granularity, it gives you adequate procedures, it gives you adequate techniques, it builds managerial into methodology. Method thus got stabilized. So, approach, methodology, method, procedure and then technique. So, method is well positioned, it will also help you hopefully in choosing a language. Now that language choice and approach at that level is not being considered seriously. If OOAD is done using some method, choose the language, press the button, you will get the code. Inheritance, dependency, usage relationship. CRC cards, they are aggressively informal, use class, responsibilities and collaboration. Most of the times we do that. We may not call it CRC, but most of the times we do. There is a degree of informality that exists. Use class, responsibilities and collaboration cards to design the system as a team. The biggest value of CRC cards is to allow people to break away from the procedural mode of thought and more fully appreciate object technology. CRC cards allow entire project teams to contribute to the design. The more people who can help design the system, the greater the number of good ideas incorporated. However, the limitation of CRC may be dozen numbers. This was one class was usually spent in the early days of teaching OOAD to give a sample problem and let people do some at the PG level, do some CRC card. This was there so many things are like that. So, what is a CRC card? A CRC class responsibility collaborators card represents a class in an object oriented design. It is a class name, a class description, the superclasses, whether the class is concrete or abstract. Concrete is tangible, abstract it is just abstract. A list of responsibilities, the names of 0 or more collaborating classes for each responsibility. This is one class, to what other classes it is connected to. What does this class do? What are the connected classes do? What is a superclass? What is a subclass? That is all it will tell. The technical term is class, responsibility and collaborators. We will talk to a few other people, do that. A small team, we are all talking to each other, each one has our responsibility, each one has a different exercise. I belong to a different class of people here because I teach, the cameraman is there, different roles distinguish the various people. The ideal group size of CRC card session is 5 or 6 people. The group 5 or 6 people in the core group should be composed of developers. Any beyond 5 to 6, even in hierarchy, it has not been yielding good results because of our short term memory. We cannot track more than 4 or 5. There is a nice managerial theory that says that each one of us can track 7 things. We cannot track more than that. 7 ideas we can remember, 7 things we can remember. In the web world, they are telling 9. We can remember 9 things in the world of web. But then there is a human limitation. The human short term memory is capable of allowing you to track 7 things. Well, we are not talking about people who can break these barriers. Anything can be broken with adequate training. Keep training, keep training. We have been talking about some what are called memory enhancement exercises. I have come across some people who have been talking like that, saying that you please have somebody doing this course for so many days, nothing will be forgotten by them in a lifetime. These are certain simple exercises which train the human mind and nothing will be forgotten. Well, I keep quipping that unless I become adequately absent minded, I cannot become a professor. So, therefore, I can forget, I can do lot of things. In the initial analysis phase, there should be 2 or 3 domain experts, one object oriented technology facilitator and the rest of the group made of people who are responsible for delivering the system. There is a whole lot of demands for a small simple task of 5 to 6 people. It does not talk much about deployment, it only talks about classes, how they are related to one another, how they collaborate to do what. Each class does this, each one has a role, each one is a different class. As the project moves more and more into design phase, some of the domain experts can be replaced by developers. Now, this was becoming a big ask. The composition of the team for just 5 to 6 people, it was becoming too much of a demand. It is good, it is a good start to understand, get a map of the classes, responsibilities and collaborations, but then it is very limited. So, a typical card is like that. You should know how to read the card, pass the card, get it ticked whether it has been done or not, and gradually the design emerges. The exact format of the card can be customized to the preferences of the group, but the minimal required information is the name of the class, its responsibilities and collaborators. The back of the card can be used for a description of the class. During the design phase, attributes of the class can be recorded on the back as well. One way to think of the card is the front as the public information, back as an encapsulated implementation details. This idea was always there. Computer programming started with Hollerith cards, the punched cards. We were all given the used punched cards to write our code and submit. That used to be repunched and we used to work on it. It was very easy to recycle the cards. We can save paper on that. Creating classes, the first step in modeling a system in the object oriented paradigm is to identify the class. After the class have been chosen, pass out cards and assign the class to the member of the group. Each person should be responsible. It is a good activity, 1 or 2 lectures it can take for a small problem. This is a set of responsibilities. Reasonable set of classes have been assigned to the group. Responsibilities can be added. Add responsibilities that are obvious from the requirements of the name of the class. The name of the class should tell what it should do. Super and subclasses, attributes, scenario execution, these are the heart of the CRC card session. We create scenarios and walkthroughs to find out whether it is working as it should. How will you test? How will you find out whether what you have implemented is working or not? We construct a scenario, and if the scenario is responding correctly, it means it has been done. Which class is responsible for this function? The owner of the class then picks up his card. When a card is in the air, it is an object and can do things. The owner announces that he needs to fulfill his responsibility. The responsibility is defined into smaller tasks if possible. So, at a time when the scenario is given, whoever is having that card will be the person who is responsible for that scenario first. These smaller tasks can be fulfilled. The idea is obvious, limited scope, 5 to 6 people, many times it is sort of asking too much for a small problem. So, we have done OOA methods, we have done OOD methods, some of them are both OOAD methods. So, essentially there is no end to these methods, there are many more, so many things are there. I have practically chosen about 8 or 9 methods which are easy to understand, bringing to the common page, very small methods, limited in scope, capacity of about 50,000 LOC is what we normally use to estimate on these methods. They are easy, you can try it out, that is a typical classroom kind of an exercise is possible. There are more methods, there are many more methods than what I have discussed, many more can come. There have been method wars, people have not been seeing one another eye to eye. We have had difficulties in translating these methods and methodologies into object oriented software engineering, fitting them into various life cycle phases, making them work in a manner where we get the software that we are having in mind done properly with good success rate, that is high quality parameters, high business conformance, good technology use. This is only a technology idea, the third rank in our priorities in software engineering, and then it tries to connect people, that is the strength, people, procedures and resources, all in a manner where we are putting together like we have some building blocks and then we put together. There are so many methods, there will be more methods to come. So, if we start fighting over these methods, we are losing completely the problems or the program or the software, that is what I have been explaining. So, gradually we learnt how to use methods. Over a short span of 5 years, most of them got thrashed out. Many of the things that I have spoken are only for academic interest. The entire book of Ian Graham made a completely different way of presenting the thing with UML. It was a set of methods, lot of methods are there, plenty of methods. Every day we can create one method with limited scope. So, most of them have vanished. So, effectively object oriented analysis had caught our imagination in 10 years between 90 to 2000. 90 it was almost another major software kind of a black decade. This is after the principles. With earlier time we were rationalizing, saying that we did not have that many principles, concepts and other things, therefore, we were not able to succeed. But after they have been defined and withstood 15 years in the profession, and only 5 years they started doing the practitioners approach, and 90 it was again squeaking, heading towards another black decade. 90 to 95, that 5 year spell is a good object oriented paradigm spell, but then nobody was succeeding. So, purely technology idea has not increased the success rate. Actually, the success rate was very harsh on object oriented paradigms, but then we rationalized the overall success rate is only 16%. Therefore, object oriented is even more harsh, but then it has attracted some of the brilliant minds, and the next 5 years lot of methods. By 2000 roughly most of the things thrashed out, and we somehow think that year 2000 is a good indicator of stability in terms of quality frameworks, in terms of object oriented. So many things got nicely consolidated. Then the managerial methodologies came into picture, then we talk about systems, all these things have gotten back again next 10 years. So, in summary, we should understand that method is useful. How to take this method into object oriented software engineering remains a challenge. One method that is most promising is unified modeling language. It is very nicely taking us into object oriented software engineering, and what is more, you can have a case tool for that. You can have a tool developed to help us. Because of these two reasons, and because of a brilliant design consistency across so many methods done by object management group, we have all taken to unified modeling language. This will be the subsequent lectures. Thank you. We will meet again in the next lecture.